Here's my lesson time management for a typical 45-minute class. The first minute or two, I like to open with a bell ringer, a question from the previous lesson, so that as students are logging on to the online session, they can get a quick review. Then 2 to 3 minute overview of their new learning targets and objectives. 3 to 5 minutes, when possible, of a real world application of their new learning targets and objectives, followed by a 2 to 3 minute discussion of this real world application video that they've seen, followed by 5 to 7 minutes of a guided practice of the new learning targets. And this is where I start my gradual release of responsibility teacher model. Then the next 20 to 25 minutes is when the opportunities for differentiated independent practice occurred. And then the lesson wraps up with 5 to 10 minutes of an extension activity, which ends with an exit ticket. And the extension activity is targeted both at the advanced learners as well as the non-proficient learners, which you will see in my demonstration lesson coming up. So the lesson that I'm going to demonstrate today has to do with finding missing legs and hypotenuses of right triangles using the Pythagorean theorem. So they've already had a lesson introducing the Pythagorean theorem. At this point, I would take a poll of all the student responses that have been entered in the chat. I do like to keep the chat on private during the bell ringers so students are not self-conscious about getting the answer correct. And then I would review the answer that is correct and why it is correct and ask the students to refer back to their notes from the previous lesson. I can use the Pythagorean theorem to find the missing hypotenuse. Remember, the hypotenuse is side C. It is the slanted side, this side right here. Or I can use the Pythagorean theorem to find the missing leg in a right triangle, which these are the two legs, A and B. And it doesn't matter. I usually tell my students just to do a method that you remember to do over and over again. I like to get in the habit of calling the shorter leg A and the longer leg B, but it doesn't matter. You can reverse those. What does matter is that you always call the hypotenuse C, because notice it comes after the equal sign. During the real world application video, I'll post my discussion question that I want the students to respond to in the chat, but now I have the chat set on public so they can interact and respond to the their peers in that discussion. I also am setting up on my virtual background that you can see in the upper right hand corner another real world application of the Pythagorean theorem. That's why you see a baseball diamond, because in the next lesson the students are going to be asked to use the Pythagorean theorem to figure out the distance from home plate to second base on a baseball diamond.
But actually, the measurements are very precise and very accurate.
At the point where this video concludes is when we would have the discussion about the responses that the students gave in the chat, during and right after the video. But since I don't have live students in front of me right now, I'm going to move right into the guided practice section of my lesson. I want you guys to be careful when you're doing Pythagorean problems, because this is very important. The first thing you have to figure out is what's missing. Is it the hypotenuse or a leg? So if you have a problem like this first one where you're missing a leg, you have to be careful when you're setting up your formula. Remember, I like to get in the habit of calling the shorter leg A, the longer leg B, but it doesn't matter which you call which. What is important is the hypotenuse is all we see. So when you're working out problems using the Pythagorean theorem, you always write down the formula first. Don't start plugging in until you've written it down. And I'll show you why that's important. So as soon as I plug in, notice I don't know A, so I leave A as A squared. I know that B is 12, so I plug it in like this. And I know that C is 15, so I plug it in. Okay. But to solve a problem like this, on the next step, because we don't know A, so we're going to end up with A squared plus 144. You should be writing this down in your notes. The problem that I'm doing equals 225. Notice here you have to subtract to find A squared. So I'm going to subtract 144 from both sides. Okay, 144. And when you subtract 144 from 225, these cancel. And I get A squared equals 81. So if A squared equals 81, A is going to be the square root of 81, which is 9. So notice how I had to use subtraction to find the missing leg. But if you have a problem like this, where it's the hypotenuse that's missing, in this case, you're going to add because you know both legs. So you're going to take A squared plus B squared equals, I'm going to identify always the hypotenuse is C, the short leg is A, the long leg is B, but it doesn't really matter if you mix those up because you still have, you're adding them. Okay, so I've got in this case A squared plus 16 squared equals C squared. So in this case, when I'm solving for side C, I've got 64 plus, and this is why I wanted you to have your calculators out, because some of these you're not going to have memorized. Okay, so that equals C squared. But some of them do not come out to an even number. So if you get something like this, 320 equals C squared, you have to take the square root of 320 on your calculator to get C. Go ahead and do that right now and type the answer in the chat. What is the square root of 320? Do it on your calculator. And I want you to round it off to the nearest whole number because you're going to get a decimal. So I want you to give me the answer to the nearest whole inch. Thank you, Tommy. No, that's not the square root of 320, Nalea. Do it again, please. Thank you, Ephraim. You're correct. No, do it again, Cash. You want the square root of 320. Round that off, Maria, to the nearest whole inch. Liz, round your answer off to the nearest whole inch. Okay, Maria, you're correct now. Cash, you're correct. Adriana, you're correct. Liz, you're correct. Okay, if you do this carefully, you will find out you're going to end up getting like 17.88 on your calculator. If I asked you to round that off to the nearest tenth, the answer would be 17.9. But because I said the nearest whole inch, you go over to the 7. And because this is a 5 or greater, you round it off to 18. Okay, in the last 10 minutes, I want you guys to go to this Desmos activity. I'm going to give you the direct link in the chat so that you don't have to take the time to go to student.desmos.com. You can just click on the link and get started. There are 11 slides that I want you to get done in the next 10 minutes. So that's about 1 slide per minute. which should be very easy for you to accomplish. Just go one slide at a time, answer the questions on the slide, and then hit next. And I'm going to pull up my teacher Desmos so I can see who has correctly gotten started. During this 15 to 20 minute independent practice time of my lesson, and I love using Desmos quite a bit with math lessons because it's so hands-on. For the students with IEPs on reading goals, Sarah, Luther, and Jaden, I would read the slides out loud to them as they're going through those. And then for those students, Sarah, Alicia, Jaden, who have math goals on their IEPs, I would allow them to use their Desmos calculator as they're solving the problems. Okay, yes, Caleb, I see you're done. Jackson, I see you're done. Michael, are you? Yeah, you're at slide 11, Michael. You're good. 2 more minutes for the rest of you to get to slide 11 and get your 3 extra credit points. About 2/3 of the way through the independent practice differentiated learning time, where I'm gradually, releasing the responsibility of the teacher, I will introduce an enrichment activity for those students that get done early. But not only is this enrichment activity for the advanced students, it's also for the students that are non-proficient as well as the proficient students. Because what I will do is I will take a question like this, and for the advanced students, I will ask them a higher level synthesis question like, using this particular picture, I want you to derive the Pythagorean theorem. Whereas for the non-proficient, the low-performing students, and those students on IEPs, I will actually guide them through the derivation of the Pythagorean theorem formula as I'm about to demonstrate coming up. We square 3. 3 times 3 equals 9. Notice the area of a square that's 3 by 3. That's what happens when you take 3 times 3. You get 9 squares there. This down here, if you square 4, you get an area of 16. Okay, that's 4 times 4. Okay, so far we took 3 squared. Then we're going to add 4 squared to it. And what does that give us? That gives us 5 squared, because 5 is the length of the slanted side of the triangle. This side right here, the hypotenuse, if you square 5, you get 25 squares up there. So 9 plus 16, the area below the right triangle, equals the area above the hypotenuse. Okay, so there's the Pythagorean theorem right there. A squared plus B squared equals C squared. So to get the answer correct, you would have had to say that the area of one of the legs is 9, when you square it. The other leg, 4 times 4 is 16. When you add 3 squared plus 4 squared, it equals the square of the hypotenuse, 5 squared, which is 25. Finally, I will end my lessons with an exit ticket. And the question that I ask on the exit ticket is going to be targeted more towards the students that are kind of on that range between the not proficient students and the proficient students, because I want to make sure that the majority of my class gets the exit ticket correct and they're feeling really good about themselves at the end of the lesson. So you'll note on this particular exit ticket, I'm not asking them to find the length of the missing side, but I simply want to know that they can identify, is it the hypotenuse that's missing or the leg that's missing, because that's critical in them then being able to find the missing side.